All right, welcome in everybody. Welcome into part 2 for percentage word problems. And this is where we're going to work backwards. So in today's game plan, we got three main things, and it's an extension of that previous lesson where we're going to go ahead and learn about using the percent formula, not to solve for the result, but actually working backwards to solve for the percent or the original amount. And so when we do that, we're going to come across operations with decimals. So that's something that we're definitely going to take a moment to go ahead and refresh on before going into those word problems again. That way we can work on picking out those key words so we know if we're going to multiply or divide rather quickly. So again, today, right here, this is a follow-up from that previous lesson. I would definitely take time to review that first if you haven't had the chance to already. So with that, let's move over here to our first set of notes, our main notes. And so let's go ahead and take this down. When it comes to using a percentage in an equation, we know this if we're here in part 2, having already gone through part 1. We know that when we're using a percentage in an equation, that we're converting it to a decimal. So if we're, kind of thinking about how that would look, it would simply be right over here and saying, hey, if we're calculating 25% of, let's say, 70, well, to actually work with that percentage inside of the equation, we have to convert it to a decimal, which means we're going to move that decimal twice to the left. So that'll actually give us 0.25 multiplied by 70. So again, just a fresh, nice, quick reminder about how to go, let me highlight this for you, how to convert to a decimal. Now, if we are thinking about working backwards, so when we're working backwards, my party people, well, we are trying to get the percentage at the end. The problem is, though, when we're working backwards, when we're solving the equation, everybody, when we take a look over here, what form is that percentage in inside of the equation that we have here? Inside of this equation, what form is the decimal going to be in? Because it's not listed as a percent anymore. It's listed as a what? Yeah, it's listed as a decimal. And so because of that, we have to understand that when we're solving for that percentage, it's going to be in decimal form. It's going to be in decimal form. So for example, if we're doing something to the effect of, hey, blank percent times, let's say 80 equals 20, and then we go ahead and do our solving, well, we'll end up getting the percent, quote unquote, equals 0.25. Now that is in decimal form. And so what we must do, everybody, is turn it back into a percent. And all we're doing is working backwards. When we wanted to go from a percent to a decimal, we would move it twice to the left. And that's what would give us 0.25. But to work backwards, we're not going to go twice to the left. We are going to go twice to the right. So all we would need to do at this point is take the 0.25 and we would go again twice to the right, signaling right here, 1, 2, and there we are. And that would be 25%. My party people, do you get that simple but very important rule when we're trying to work backwards, when we're calculating that percentage? It's going to be in decimal form. We just have to turn it back into a percent. Let me highlight that right there. To turn it back into a percentage, move the decimal twice to the right. Right over there. 0.25, move that decimal twice to the right, gives you 25%. Just remember, in the same way that we go from percent to decimal, twice to the left, working backwards, we go twice to the right. That's all I'm trying to express. Again, straightforward, but easy to forget. So I got to emphasize it a little bit there. So with that said, everybody, are we good to move forward to the next example or the next set of, we're going to look at the first example actually right away. All right, perfect. Sounds good. So let's go ahead and hop it over here. Here is the first example that we're going to work on. All right, let's take a look at this example. We're dividing 42 by 0.7. So before we actually get to doing the full mechanic of, calculating that percentage, we're going to begin first by just learning how to work with decimals. So my party people, go ahead and let me know right over here, 42 divided by 0.7. Everybody, are we used to dividing by decimals? Or is dividing by decimals something that gives you a little bit of anxiety? Yeah, I figured not everybody's used to it. And that's okay. That's absolutely okay. Now, let me go ahead and kind of walk you through. So, remember this before I even get started, the rules for multiplying and dividing by decimals are two different sets of rules. So, just as a reminder, when it comes to multiplying by decimals, you ignore the decimal until the end and then you bring them back. When it comes to dividing by decimals, here's the main thing: to divide by a decimal, don't. Don't divide by a decimal. That's it. That is the only rule. Don't do it. Now, how you don't do it, watch this. My party people, give me a yes or no in the chat box if this sounds familiar. When it comes to fractions, whatever you do to the top, you do to the bottom. Does that sound familiar to anybody? Whatever you do to the top, do to the bottom. Yeah? All right, cool. So, everybody, now take a moment, grab your calculators, whether it's on your phone or if you have a calculator in front of you, go ahead and do this calculation. Do 42 divided by 0.7. Tell me what that's going to give you. Tell me what that's going to give you. Yeah, that's going to give you 60. 42 divided by 0.7, that's going to give you 60. Now, let me show you how we can very easily get there. Again, we are going to manipulate the fraction. So, move the decimal on the top and the bottom, on the top and bottom until you don't have a decimal. Until you don't have a decimal. And specifically what I'm saying is until you don't have a decimal on the bottom. Because again, we're dividing by a decimal. We don't want to do that. The easiest way is like this. Everybody, how many times do I have to move this decimal right over here? How many times do I have to move this decimal so that way the 0.7 turns into a whole number? No, not to turn it back into a percent. That's not even the conversation right now. How many times do we move it so that 0.7 turns into just 7? Just 7. How many times? Yeah, just once. Exactly. Look at this magic. Pay real close attention. Don't even write anything down. I'll give you a chance to write something down in a moment. Watch this. I'm going to move it one time over to the right. And everybody, because we're trying to follow the rule of fractions, whatever we do to the bottom, we do to the top. How many times do we move it on the top? Yeah, we're just going to move it one time. Exactly. We're just going to move it one time. And in what direction, everybody? Again, we got to do the same thing. So what direction? Is it going to the left or to the right? Which way is it? Yeah, it's to the right. Remember, look it over here. Let me zoom on in to show you. We move the decimal place over one time to the right. So all I got to do is the same exact thing up here. Let me just copy this over. The same exact thing up here. And my party people, help me out because I'm not crazy. I don't see a number in there, but what number belongs in there? Yeah, that's going to be a 0. That's going to be a 0. So what did I just do? I did the one thing that we all know. Whenever you're dealing with fractions, whatever you do to the top, do to the bottom. And I did that so that I don't divide by a decimal. It's a whole number now. It's a whole number now. Does anybody feel more at peace when they're dividing by a whole number versus a decimal? Yeah, that's the point. It's an easy division now. This is an easy division now. Here's what I mean. Let's go ahead and do the division. Look at how straightforward it is now. 7 going into 420. 7 goes into 4. Well, it doesn't. But 7 goes into 42. Absolutely. That's going to be 6 times. So 7 times 6, that's 42 exactly. No remainder there, but we drop that 0. 7 goes into 0 times, and check that out. We get the answer that we got with our calculators there at the beginning, and we can do it by hand. And we can do it much faster than we just did it, because obviously this was the first example. But I hope you can see that dividing by decimals shouldn't have to feel that confusing. Is anybody here seeing what I'm saying? Seeing, picking up what I'm putting down when it comes to just, hey, whenever you're dividing by a decimal, don't. Just don't. Give yourself an easier time by moving that decimal place on the top and the bottom the same number of times until you don't have a decimal anymore. From there, then divide, and you're all good. Life's easy. Anybody here want to try one of these on their own? So we want to perform the division of 18 by 0.25. All right, so let's go ahead and tackle this together by first setting it up like a fraction. 18 divided by 0.25. And the point here is, like we've been saying, that to divide by a decimal, just don't. I am going to move that decimal place over in that denominator. I'm going to move it as many times as I need to not have a decimal at all. So let me just copy this over to show you what it's going to look like when I do it. So I'm going to move that decimal place over once, twice. So that's twice in the denominator. So I am going to do it the same number of times on the top. So twice on top, 1, 2. And just like I might, you might think I'm going to ask, well, what number do I put in that blank space? Yeah, it's going to be 0. The blank spaces can always be filled by zeros. So what we essentially have, everybody, is 18 over 0.25 is the same thing as 1800 divided by 25. That's what the math says. That's what your rules of fractions tells you. That's what makes this so much easier than thinking about that decimal. So with that, let's do it. Let's set up the long division 25 going into 1800 right over here. And so let's plug it in. Here we go. So 25 can't go into 1, doesn't go into 18, but it does go into 180. So we'll go ahead and calculate that. 25 goes into 180 how many times, my friends? When we think about it, 4 times is 100, 5 is 125, 6 is 150, 7 is 175. So yeah, we would definitely use 7. And so we'll subtract 175, giving us a remainder here of, right there, 5. And so then we drop that 0, and we ask ourselves, how many times does 25 go into 50? That's an easy one. That's going to be 2. And there we go. The final answer here is 72. And we're good. And if you don't believe me, again, take a moment, grab that calculator, and do 18 divided by 0.25. And there you are. So my party people, are we feeling good about division by decimals? Are we feeling good about this as we move forward? All right, sounds good. So let's keep it moving forward. Let's try another problem out. So here we have 56 divided by 0.8. So to get this division done by a decimal, well, we want to get rid of the decimal. So we have 56 divided by 0.8. And as a reminder, the one rule that we are doing or using is whatever you do to the bottom, we're gonna do to the top. This is gonna help us manipulate the fraction, but not change its truth. So what we're gonna do is, again, whatever we do to the bottom, I'm gonna move it once to the right. That's gonna give me 8, not 0.8. Okay, I'm gonna do the same to the top, once to the right. So 56 becomes 560. And there we are. That's all we had to do to give ourselves better positioning to get this done without the headache. So that's it. We're good. We're done. We will do 8 going into 560. We know that 8 goes into 56 7 times. And then we subtract the 56, leaving a 0. And then 8 going into 0 will just be 0. And there it is. A problem that when you look at for the first time might make you have a little hiccup, but then when you understand your rules can become a lot more of a point of excitement because you know how to calculate it and you can feel confident moving forward. So with that, we are now at the point where we can move forward to incorporating this into some percentage formulas. So let's take our attention over here. Let's check this out. This problem starts by saying 12% of some number is 48. What is that number? Okay, let's go ahead and get after it here, everybody. So when we understand and remind ourselves about this formula, we have the formula as percent times original equals the result. And remember, we are taking, what we multiply is the percent by the original number. If we're saying that the percent of some number without identifying that number, well, that's going to be the original that you're looking for. Point in case, I'll show you right over here. We have 12%, so let me write that down. 12% of, everybody, what does the word of mean again? What operation is that? Not out of, just of. Yeah, that's multiplication. So that's right over here. That's right over there. Multiplication by some number. So I'm going to put a blank there. The word is means equals. So I'll go ahead and just write the equal sign. And then we have 48 right there. So everybody, when we take a look with just our eyes, do we notice that when we plug everything as it's written, do you see with your eyes that we actually have the result and we're looking for the original? Does that make sense to you visually before we continue? Cool. So that's the first step. We just want to understand that, hey, what do we have? What are we looking for? We see that we are looking for the original value right here. So how are we going to get that original value? Well, we're going to work backwards. Everyone, if moving forward, we are supposed to multiply. If moving forward, we multiply, what do we do when we work backwards? Yes, we're going to divide. Now, here's the good question, though. What are we going to divide by? What are we dividing both sides by? Let's see who knows this. We are going to divide both sides by, I see a couple different answers there. The first one that really takes my attention is the 12. That's wrong. That's incorrect. You're almost there. Everybody, what did I say we must do whenever we are incorporating percentages into an equation? What do we have to make sure we always do again? Starts with a C, and it's not cancel. What are we always going to make sure we do? Yeah, we got to make sure we convert the decimal or the percentage to a decimal. So right over here, let me just go ahead and put some stars. We have got to convert it first. So we are supposed to actually be working with once, twice to the left, 0.12 times the original equals the result. That's what we have to make sure we're doing, everybody. I know, when we're dealing with everything all at once, it can feel overwhelming. That's why it's important to work through these examples first. So, what are we dividing by again, everybody? Help me out. What are we dividing both sides by? Yeah, 0.12. Exactly. There we go. So now that we know that, let's go ahead and draw it out. Dividing both sides. 0.12, 0.12. Perfect. We have everything we need now to finish the problem up momentarily. Here's how we're going to do it. Let me just copy this over, duplicate you over here, and let's take care of business. The best way to divide by a decimal is by not dividing by a decimal, and that's going to be by, again, just getting rid of the decimal and doing the same thing up top. So we're going to move it 2 times to the right on the bottom, which means we'll move it twice to the right on the top. We fill those gaps in with zeros, and that's going to be 4,800 divided by 12. That's the new division. 48 divided by 0.12, mathematically speaking, is the same exact calculation as 4,800 divided by 12. So with that said, let's calculate this here. We can do long division or use our knowledge, but I'll do 12 going into 4,800. 12 goes into 48. That's going to be 4 times. Subtract that 48 with nothing left over. So we'll just bring those zeros down, and that's going to be 400. And there we are. We've just completed our first problem where we've worked backwards to find the original number. You should be proud of this. You should feel pretty good about this because putting this into a complete word problem is just about putting this piece together. Once you get to this point, you can do the rest of the calculation nice and easy. So let's give this next one a shot and let's go through it faithfully. Let's go through it faithfully, step by step. Because remember, the last thing that we want to do is make assumptions, memorize what we see and think that that's how everything's going to be. We want to come from a place of understanding instead of memorization. So here we go. We want to know, what is the number? Okay. And we're told that 7.5% of some number is 21. This is where a lot of us would look at this and say, either I'm not going to try or I'm going to be nervous 90% of the time. But let me walk you through this. First thing that you want to do is identify the relationship between this number that we're looking for and the information we're given. And all I got to do really is just translate this word for word into an equation. Watch. 7.5%. Everybody, 7.5% is right there. One more time, the word of means what operation? The word of means multiply, in this case, right on. And then we have some number. So I'll just go ahead and put a blank right there. The word is means equals. And then we have 21. So take a look at that. Boom, 7.5% times some number equals 21. Everybody, based on our formula, percent times original equals the result, do we notice that we are trying to find the original value? And that's step one. That's just step one. Just visualizing it, understanding what you have and what you're looking for. Step two is putting everything in its proper place. So what I mean by that is, one more time, everybody, is this percentage supposed to stay this way when we calculate? Absolutely not. How many times am I moving that decimal place over? How many times? Always. Non-negotiable, no matter what. No matter what, when we are converting between percent and decimals, it's always twice, no matter what. Because to convert between percent and decimals, percent means out of 100. 100 meaning 2 zeros, 2 place values. So we are going to take a look at that and go once, twice, meaning we'll have a 0 right there. So it's going to be 0.075 multiplied by the original equals 21. And now that we're here, again, we moved that decimal place twice. Now that we're here, sure, it looks a little funky. Sure, it looks a little daunting because it's, more decimal places, more place values than we're used to. But it is what it is. And we have to know how to handle this. So the next step, everybody, is working backwards. We're trying to not find the result, but the original value. And to do that, we have to work backwards and divide both sides by what's in the way. What's in the way? The 0.075. When we divide this on both sides, look at this. The left side cancels out. That's half the journey. And now we're on the second half of the journey, the harder part, which is, oh no, dividing by a decimal. But we've gone through this before. We have gone through this before. We know how to handle this. All we have to do, stay calm, cool, and collected, everybody. All we have to do is move this decimal place over right there. Move that decimal place over until it's no longer a decimal. So we have once, twice, 3 times. Let me go ahead and zoom on in for you so you can see it nice and easy. Once, twice, 3 times. Can we all confirm that I moved it 3 times up here? Can we confirm that? All right, sounds good. Now that we've confirmed that we're moving it 3 times to the right on the bottom, how many times and in what direction are we going to move it up top? Yeah, it's going to be 3 times to the right. The exact same thing. It's not anything crazy. It's not something secretive. It is something consistent. That's what math is. It's consistent. So we have 1, 2, 3 blank spaces that we'll fill in with zeros. So what we can say so far is that 21 divided by 0.075 is the same thing as doing 21,000 divided by 75. It's the same exact thing. So now all we really have to focus on is 21,000 divided by 75, and we are done. So let's go ahead and do it. Everybody, if we're dividing 75 into 21,000, we're going to go ahead and get this done. So you can use your calculator at this point if you just wanted to understand the decimal side of things. But now that we're trying to do some long division, let's get it done here. So the first thing you want to ask yourself is, hey, does 75 go into 2? No, it doesn't. Well, does 75 go into 21? Well, no, it doesn't. So I'm going to continue. Does 75 go into 210? It does. And I see some folks here in the chat box saying, yeah, it's going to be twice. And yeah, let's prove it. Let's prove it. Let's make sure that we're not jumping the gun. Let's do 75 times 2, and let's do 75 times 3. So 75 times 2, that's going to be 5 times 2 is 10, and then 7 times 2 is 14. Carrying that 1 is going to give us 15. Okay, so 150. Now if I check out 75 times 3, 5 times 3, that's going to be 15. Carry the 1. And then we have 7 times 3 is 21. Carry the 1 is 22. So everybody, which one is it going to be? Is it the 2 that belongs up here or the 3? Which one is it? Yeah, it's going to be the 2 because 225 is too much. So it has to be 75 times 2. So I'll do that. I'll write the 2. And let me just get rid of this right there. And we'll have minus 150. Everyone, 210 minus 150 leaves us with a remainder of what? 60. That's correct. 0 minus 0 is 0. 21 minus 15 is 6. So that's going to be 60. So up next, we're going to drop that 0. And now we're going to ask ourselves, oh boy, how many times does 75 go into 600? Oh man, I don't want to do so much work today, but hey, it is the price of admission for success. So let's go ahead and get it done. So let's keep doing our guesstimation. 225 is a little small there, so let's go ahead and up that number. Let's go ahead and try 75 times 7, and I'll try 75 times 8. So let's do times 7. 5 times 7, that's going to be 35. Carry the 3. 7 times 7 is 49. Carrying the 3 is 52. Okay, so 525, pretty close. But let's see if we can get even closer. 75 times 8. 5 times 8, that's going to be 40. Then we have 7 times 8. It's going to be 56. Carry that 4, and that's going to be 60. Oh, look at that. That's a perfect 600. Exactly what we see there. So it's absolutely going to be 8. I subtract the 600. 0 left over. No more remainder. Boom. And that is 280. So overall, the answer to this question, 7.5% of some number being 21, what's that number going to be? That number, my friends, is going to be 280. And there we go. That is how we kind of put it all together there when it comes to working with the decimal, the percentage, and that long division at the end. How are we feeling so far? Are we feeling ready to tackle more? So let's try this example word problem where in this word problem, with these choices that we have, let's understand what we're getting into. So the first thing that we do is we read the question sentence. And the question sentence says, about how many soldiers were in the exercise? And we have our answer choices over here. But the main thing is about how many soldiers were in the exercise. Okay, so let's take down the information we have so we understand if we're working forward, working backwards. Let's really give an opportunity to the problem and the story of the problem to make sense. Here it says, during a field exercise, 18% of the soldiers, look at that, 18% of the soldiers, so 18% of the soldiers, which is exactly 45 people, were assigned to reconnaissance. Okay, everybody, 18% of the soldiers, which is 45 people, were assigned to reconnaissance. How many soldiers were in the exercise? My party people, is it clear to you that when we read the sentences, 18% of some number that we don't know is 45 right over here? 45 people, that's the result. 45 is 18% of the number of soldiers. Everybody, which are we looking for here? Are we looking for the percent, the result, or the original value? What are we looking for according to our formula? Yeah, according to that formula, we're looking for the original value. We're working backwards. That's what we notice. Now, at this point, if you're confident or not with dividing by decimals, that's not the question. The question is, can you understand that we're looking for the whole number of soldiers for this exercise? That's the big thing. And that being identified as the original value is going to work wonders for you. Now let's get to it. Let's solve. Because we know that the word of means multiply, so we have 18% times the number of soldiers, and that's going to be 45. But don't forget, if we're going to be dealing with the equation, This percent cannot be a percent anymore. We have to turn it into a decimal. And so to do that, remember that we take that decimal that was there and always move it to go to a decimal. We move it twice to the left. So that's 0.18. And similarly, that's what's going to be divided on both sides because we're working backwards. Again, to get the result, we multiply. To get the percent or the original, we divide. So in this case, everybody, we're going to divide both sides by 0.18 right there and right there. And once we do that, we cancel out on the left and we see that our final answer will be 45 divided by 0.18. This doesn't seem like a lot of fun, right? Dividing by decimals. But all we have to do is not divide by a decimal. So we'll take that decimal place, move it once, twice to the right, and we'll do the same thing up top. Once, twice to the right. And so what we are going to do is fill in those zeros where they belong. So the same thing goes, it's 4,500 divided by 18. So now that we're here, we will do 4,500 divided by 18. We can do that as long division over here on the side, just like that. And we can get it going. So 18 going into 45, how many times does that happen, my party people? That's going to end up being twice. That's right. 18 times 2. 8 times 2 is 16. 1 times 2 is 2. Carry the 1 is 3. So yes, that is going to be twice. We subtract the 36. Everybody, how far is 36 away from 45? Yeah, they're pretty close. That is going to be 9. And now that we have this 9, we're going to drop a 0 and continue going. So now we have 90. And so 18 goes into 90. How many times? I see a lot of us saying 5. Let's confirm that. 18 times 5. 8 times 5 is 40. 1 times 5 is 5. Carry the 4. That is 9. That is correct. So we have a 5 right there, and that's a perfect 90. Drop that last 0. Boom. Just fill that back in. And we are good. There's our answer. Our answer is that there were 250 soldiers at the exercise. The 45 people, that represents 18%, those were the ones assigned to reconnaissance. But in total, there were 250 soldiers present at the exercise. And there we are, everybody. Take that in. Really go over your reasoning and the reasons for why you believe you were right or wrong. All right, here's another problem that we want to take care of. As always, we're going to begin with the question sentence. So it says, how many students took the test? That's a pretty straightforward question. I like that. How many students took the test? That's all we care about. How many students took the test? All right, cool. So to find out how many students took the test, let's get a little context. The context here says that a skills test reports that 62% of students passed. Okay, so we'll say 62%. That means the number of folks that passed. Everybody, the way that we can interpret that is like this. We can interpret it as 62% of the students passed. Everybody, is that a proper way to interpret that? Is that logically sound? Does that make sense to you at face value? If we're saying 62% of students passed, that means 62% of the students that we have equals the number that passed. That's what that means. And everybody, can you tell me in this problem how many students passed? How many students did they tell us passed here? What is that number going to be? Yeah, that's 155. Right here, totaling 155 students. So we'll grab that. That is the number of students who passed. 62% of students passed, and that's 155. So what I'll do is I'll set up my equation, converting my percent to a decimal twice to the left, giving me 0.62. Multiply by the number of students, which is the original amount that I'm looking for. And I'll replace the number for the number that passed with 155. So from here moving forward, my next goal is to divide both sides by the 0.62. I want to get the number of students by itself. That's all I want to do. And when I do that, we're going to cancel out on the left, leaving me with students equals 155 divided by 62, or excuse me, 0.62. Getting ahead of myself there, right? So we'll grab that, we'll duplicate this right over here, and we're going to remind ourselves of how to divide by decimals, which is by not dividing by decimals. I'm going to zoom in, move that decimal place once, twice to the right, and whatever you do to the bottom, we are going to do to the top. Once, twice, and we'll plug in those zeros, meaning that 155 divided by 0.62 is the same thing as doing 15,500 divided by 62. It's the same thing. And I think we can find this a little easier, a little more attractive than, the decimal version. So now that we're here, let's get it done. You might even notice that both of these are divisible by 31. You might notice that, but if you didn't, no worries. We can go ahead and do long division. 62 going into 15,500, just like that. So here we go. 62 going into 1, it doesn't. 62 going into 15, it doesn't. Then 62 going into 155, everybody. How many times does 62 go into 155? Yeah, that's going to be twice. Let's write that here on the side just to confirm. 62 times 2, that's going to be 4, and that's going to be 12. That's 124. That's pretty close. And I know if I added another 62, that would be too much. So I'm going to write over here 2, subtract the 124, and that's going to give me a remainder of 31. I'll drop that 0 right here, and I'll ask myself, how many times does 62 go into 310? 5 times? Sounds good. Let's try it out. Let's confirm. Trust but verify, right? So 62 times 5, 2 times 5 is 10, carry the 1. 6 times 5 is 30, and then carry the 1 is 31. So yeah, 310, that is correct. That is 5. And we are good because there's nothing else to divide into. So this 0 right over here, just tack it on at the end. And we're good. There it is. 250 is going to be that final answer for this word problem. Booyah right there. There were 250 students that took the test. All right, now let's take a look at an interesting problem here where we're still going to go straight to the question sentence. And it says, what percent correct is that? Okay, so we're dealing with a situation that we recognize. We're talking about a practice test. If you're watching this video, yeah, you might be preparing for a test yourself. So we recognize the situation and we want to know what percent correct is represented by this up here. Okay, sounds good. We want to know blank percent correct. That's what I want to know. So what I'm going to look at here is the main information saying a student answers 45 of 60 questions correctly on a practice test. Okay, so we got 45 out of 60 total questions. So it almost sounds like if we were to set this up like the percentage formula, it would be blank percent of the 60 original questions ends up being 45 questions correct. And remember, the percent that you apply is the result that you get. This is the right way to set it up because look at how we write it. We are looking for the percent that's correct, and we are putting the amount that's correct on the other side. The percent you apply is the result that you get. This is how we know this is the right setup and not the other way around. So now that we're here, I think this is pretty straightforward because you have this blank percent multiplied by 60 gives us 45. My party people, what's the only thing we have to do to get this correct? What do we have to do to both sides when we work backwards here? Yeah, divide. That's the straightforward answer there. We just have to divide and get rid of that 60. We got to get rid of it. So that's what I'll do. But there's one little thing that if you're not used to doing this, there's one little thing that could trip you up at the end. But let's get to this first part first. We'll divide by 60 on the left and right sides, keeping that balance in the equation. Cancels out on the left side, 45 over 60 on the right. So now that we're here, all we got to do is do 60 going into 45. And so here we have 60 going into 4. It doesn't. We have 60 going into 45. It doesn't. So now that we're here, this might be a little confusing, right? This might be a little like, what? What's going on? Don't worry. We're going to place a decimal. We're going to put a 0, and we're going to continue. Everyone, how many times does 60 go into 450? 7 times. Let's write that out. 7 right there. Because 60 multiplied by 7 is 420. When we subtract, we have 30 left. We'll take one more 0 right there, drop it to get 300. Everyone, how many times does 60 go into 300? 5 times. That is correct. And so we'll write the 5 right here. And so we have 0.75 or 75 hundredths. That's going to be our answer. But that's going to be a little weird. It's going to be a little weird because when we take a look, we have 0.75 equals my percent. What? Does that really make sense? No, it doesn't. Because remember, everybody, what form is the percent in when it is in the equation? What form is the percent in inside of the equation? What form is that in? Yeah, it's a decimal. It's in decimal form when it's inside of the equation. So what we have to do at the very, very, very end here is we have to change the decimal back to a percent. And remember, going forward to a decimal, we move it to the left twice. To go backwards, to turn a decimal back to a percent, we move it to the right 2 times. So that's going to be 75%. So that was the one last thing that we needed to do before fully, saying that we're done. But there it is. The correct answer here is D, 75%. We just had to remember to turn that decimal back into a percent at the end. And we're good. All right, taking a look at the next word problem here. The next word problem says, what percent of the run did the runner finish? Okay, so what percent of the run did the runner finish? Sounds good. So what percent? That's what we're looking for. And then we want to know the percent that represents how much was finished. Okay, blank percent finished. All right, sounds good. So let's take a look at the other information that's there. And it says a runner completes 18 miles of a planned 30-mile challenge. Okay, so 18 miles are complete or finished. And then 30 miles is the total. So 30 miles total. So if we're setting up our equation for our percentage here, it is blank percent times the total of 30 miles equals what we finished. Again, because this percent represents what was finished right there. So what we have to represent as the result is the amount that was finished. And that is represented by the 18 miles that we've completed. So that's really the hardest part. Before we get to the calculation, obviously, but that's the hardest part. Just making sure you can contextualize what you see. So now that we've contextualized it, now we can move forward to solving. So I'll just put an X for that percent. And so what we have is 30 times X equals 18. And so we just have to get rid of everything around the X. And to get rid of the 30, we're doing the opposite operation, which is going to be division. We'll divide both sides by the 30, canceling out on the left, and we're going to have X equals whatever that's going to be. So let's do the long division. Let's get there. And that'll be 30 dividing into 18. Zooming in, we see that we have 30 can't go into 1. 30 can't go into 18. So this is where I'm going to use a decimal. And then those zeros that are always there, but we don't write them down, we're going to put that there. So to do this, now we ask ourselves, well, 30 can't go into 1 or 18. How many times does 30 go into 180? And that's going to be 6. Yeah, exactly. That's going to be 6. So we have that right there, and we're done. That's it. Subtract 180, no remainder. We're good. And so we have X equals 0.6. However, everybody, what's the problem? we finished the calculation. But the problem is that, remember that percentages show up as decimals. Percentages show up as decimals. And so because of that, we have to turn it back into a percent. And it's always going to be how many times, everybody? Always going to be how many times? Twice, exactly. So we're going to take 0.6, move that decimal place over twice. 1, 2. So there's that 0 right there. So it'll end up being 60%. So completing the 18 miles out of the 30-mile journey means that you are 60% complete. And there we are. If you would have gotten answer choice D, that would have been because perhaps we divided 30 by 18 and not 18 by 30. Notice how it matters. Your setup and your solution, it really does. All right, so let's take a look at this unique example here. Let's just take a look step by step. The first part that we look at is the question sentence, as always, and it reads, what was the original size? Okay, sounds good. We want the original size. Sweet. So everybody, can we confirm that in the chat box? It says, what was the original size? So we want to say, original size equals blank. Can we confirm that? That's what we want. The units here are megabytes, so MB. Can we confirm that before we get started here, that what we are looking for is the original size? Sweet. Notice how I'm being specific there, right? I repeated myself 5, 6, 7 times on the same exact detail, but it's important to understand your grounding. So we have that. And now the next thing I'm going to look at is the information I'm given. And if you take the moment on this next step to identify your information properly, you're going to see why the wrong answer is C. I'll show you right now. Here we go. It says, after a 30% reduction, okay, let me write that down. 30% reduction, okay. It says a file shrank to 56 megabytes. Okay, so the result equals 56 megabytes. Okay, so this is going to be, everybody, you tell me that 56 megabytes is the final size. Is that right, everybody? It's not the amount that we reduced by. That's the final size, right? Yeah, it is. It says again, after the reduction, it shrank to 56 megabytes. So right there, this file is 56 megabytes. That's the final size. Why do I keep repeating these details? Why do I keep doing that? Well, let's write our formula out. The percent times the original equals the result. Let me show you why this is so important, knowing that the percent and the result represent the same thing. Look at what's wrong with this. If I blindly plug in 30% times the original equals the resultant 56 megabytes, look at what's wrong with this, everybody. It's wrong because the 30% represents how much we were reducing by. This is the reduction. Again, we reduced by 30%. And when you look at the 56, everybody, does the 56 represent what we reduced by or what we got to, what we reduced to? Yeah, this is what we reduced by. This is the final. This is what we get after we reduce. So everybody, let me ask you this. In this problem, in this setup, is the percent and is the result, are they representative of the same thing? Are they representing the same thing as we currently see it on the screen? Yeah, the answer there is going to be a no. The answer is going to be no, because the percent represents reduction. The result represents the final. This doesn't make sense. And so to make it make sense, there's one little thing that you have to do. Shout out to my folks in the chat box already putting in the work. Right on. One thing that we can do super easy here is, again, just make sure that these line up. Because I'm already given the final amount, I'm not going to do anything with that. I'm going to leave that as the final amount. I'm going to want to get the final percent. I'm going to want to get the final percent here. Let me show you how to do that. If the original size is 100%, if that's the original, well, guess what? Everybody, what does reduction mean? What does reduction mean? To reduce, what does that mean? Yeah, to subtract. So let's subtract 30% because, again, that's the reduction. And when I do that subtraction, when I commit to it, I get a result of 70%. So the result is 70% of the original size right there. This represents the final. The final is 70% of that original amount. And so what I'll do is this right here. Get rid of the reduction, the 30%. I'll put in the 70% right there. And now I'm good to go. Because I'm going to write this as a decimal, 0.7. You can write 0.70 if you want to, but I don't like giving myself too much work. I'll just go ahead and put 0.7 times x. So I'll just say times the original just to keep it easier. And now all I got to do is divide both sides by 0.7 and look at what I got. Booyah right there. There we are. Don't think that the answer is going to be 8. Be very careful. We're going to cancel out right there on the left side. And our original value right here, we can just go ahead and use our little decimal rule right away by moving it to the right once and then right to the right once over here too. So what we now have is 560 divided by 7. 560 divided by 7, that's going to be 8 with a 0 at the end, which is going to be 80. So the original file size is 80 megabytes. That is the original file size right there, B, 80 megabytes. If you would have kept the 30%, you may have gotten the 168 megabytes. That's what you would have gotten. But we have to remember that the formula matters so much. You have to consider consistency and representing everything the right way. If we do that, then we'll be in a great position every time we step to the plate. All right, next one up. The question sentence reads, what was the inventory before any were used? So again, what was the inventory before any were used? So if we're taking a look at this context here, it almost sounds like we want to know the inventory before something happened, right? Before all of this happened. So when we think about percentages, that's already a hint that we're dealing with the original amount. Because again, if we want to know the inventory before the inventory was used, we want to know that original amount of inventory. So that's one little hint. Here's the second hint. Let's read through the context. It says, a warehouse used 12.5% of its inventory today, which amounted to 600 units. Let's read that again. They used 12.5%. So again, 12.5% equals the percentage used, and that is the same as 600 units. 600 units were used. Everybody, do we see the connection? Before we continue, do we see the connection between the percent and the result? Do we see that relationship, how they both represent the same thing? One is a percentage, the other one is in the actual number form. Booyah. So what are we doing 12.5% of? Of the inventory, of that original amount. So when we write that down, it's going to be like this. 12.5% of the inventory, of that inventory is going to amount to 600 used units. And I'll go ahead and just show it again. 12.5% and 600 both represent used, which means we're good to go. We can try to solve for the inventory, and that'll give us the original amount before it was used. Sweet. So to do this, we got to be careful. Number one, we have to make sure we turn the percent into a decimal, and that's going to be 0.125. That's going to happen after we take that decimal and go 2 times to the left. From there, we're going to multiply that by the inventory. So I'll just go ahead and repeat inventory, and that's going to be 600 on the right. So to get this problem completed, we just need to get rid of that 0.125. To get rid of it, we're going to divide both sides, as we see over here. Divide both sides by 0.125, right there and there. And once we do it, we cancel on the left, and we'll perform our division. Now, we got a little bit of a problem because, we don't want to divide by that decimal. But no worries, let me copy that right over here, and let's show ourselves what we're going to do. Again, the best way to divide by a decimal is to not divide by a decimal, and we see that to not have a decimal, we're going to move that decimal place 1, 2, 3 times to the right. One more time, that was 1, 2, 3 times to the right. So we'll do the same up top. Again, with fractions, we have to keep that balance. And so that means we're going to have 1, 2, and 3 extra zeros. And so that makes this division, again, from 600 divided by 0.125, it turns it into 600,000 divided by 125. Now, at this point, you might be looking and thinking, well, coach, this is the point at which I was confused because I kept second guessing myself in terms of how many zeros because I was debating between A and C. Anybody here feel that way? Debating between A and C, not sure which one it was, which one the right one is? Yeah, no worries. I know the suspense is killing you. So let's go ahead and actually do the math. Let's finish the problem and do the math. So we have to divide by the 125, and we're dividing into 600,000, just like that. So let's go ahead and get after it. 125 doesn't go into 6. 125 doesn't go into 60, but it can go into 600. How many times do we believe 125 goes into 600? Okay, I see a couple of 4s flying out. Let's go ahead and use 4. Let's see what happens there. So we'll do 125 multiplied by 4. 5 times 4 is 20, carry the 2. 2 times 4 is 8, carry the 2 is 10. 1 times 4 is 4, carry the 1 is 5. So we have 500. And so cool, that'll end up being 4 right there. Because again, for the 600, subtract the 500, and we have 100 left over. We'll drop the 0, and that'll make it 1,000. My party people, how many times does 125 go into 1,000? Yeah, if you take a look here, you can actually figure that out pretty easy. Because think about it. If 125 times 4 is 500, well, we double it to get to 1,000. Double the 4, that'll be 8. So we can use that logic right there to give ourselves a little bit of an advantage on cutting time. But we can show it anyway. 125 times 8. 5 times 8 is 40, carry the 4. 2 times 8 is 16, carry the 4 is 20, carry the 2. And then 1 times 8 is 8, carry the 2 is 10, making the 1,000. So yeah, that would be 48 minus the 1,000, no remainder left. But notice that we have 1, 2 zeros left. So that would be 1, 2 zeros that we would place at the end, making our final answer not A, but the final answer is actually C, 4,800, my party people. And there it is. So a lot of us were close, but I want to make sure that we understand whether you got it right or wrong. Remember to ask why. That's the biggest thing always. All right, next problem. What percent of the required flour is on hand? There it is. What percent? We are looking for a percentage. So blank percent is going to be representing the required flour that's on hand. So I'll just say flour on hand. So we want that percent, okay? Now, here's the cool thing about how the problem is written. Well, what's not cool is that we have 2 decimals. So that's going to be, again, like, oh man, that sucks. But never mind that. Look past that and understand what the numbers mean. Here's what it says. It says that a recipe requires 0.45 kilograms of flour. Okay, so this is what it requires. So 0.45 kilograms is the required, okay? And then it says, but only 0.27 kilograms is available. Okay, so 0.27 kilograms is available. Everybody, when we take a look at what we've written down, regardless of if you're spooked by those decimals, which of these two mean the same thing? Flour on hand, required, and available. Which of these two of the three represent or mean the same thing? Flour on hand, okay, flour on hand means the same as what? Yeah, the phrase on hand, like how much you have on hand, that's how much you have available, everybody. How much you have on hand is how much you have available. So let's highlight that. Let's stick these together. On hand and available represent the same thing. So that means that the percent that we're looking for represents the 0.27 kilograms available. These two ideas represent the same thing. And as we know, with our formula, the percent that you apply is the result that you get. So when we plug in these values, I am going to plug in X percent that is on hand. I'm going to multiply that by the originally required 0.45 kilograms. And that's going to equal a resultant 0.27 kilograms that we have available, which is the same thing as saying on hand. Remember, the setup is the most important part first. We've got that setup, and now we can solve. So we can just clean this up and say 0.45x equals 0.27. And if we zoom in, we can see that all we have to do, again, regardless of the numbers, all we have to do is divide by that number in front of the x. And that's going to be 0.45 on the left and the right sides. We have that there and there, canceling out on the left, giving us x equals 0.27 over 0.45. And the cool thing about this is, I've told you all the time, don't divide by a decimal. So I'm going to move this over twice to the right. And guess what? I can do the same thing right up here. Move it twice to the right. And so this problem becomes 27 divided by 45. That's what this becomes. So to continue, just to finish this off, we have to divide 45 into 27, and we'll place those decimals because we might need them. So then we ask ourselves, how many times does 45 go into 2? It doesn't. 45 into 27? It doesn't. But how many times does 45 go into 270? Oh, 6 times? Let's try that out. 45 times 6. 5 times 6 is 30. 4 times 6 is 24. Carry the 3 is 27. And yes, y'all are correct. That is absolutely right. So that'll be a 6 right there, minus 270, giving us a remainder of 0. So it's just 0.6. X is 0.6, but we have to turn this into a percent. To turn it back into a percent, everybody, we're going to move it exactly 2 times to the right. And that gives us 60%. And there it is. We have 60% of the required flour on hand. And that is answer choice C. If we would have gone the other way around, 45 divided by 27, you would have gotten A. But that's backwards. That would have been incorrect. The right way would have been, again, notice our equation, 27 being divided by 45. So again, the order matters. The setup matters. And I hope that you continue this into your next practice.